In 1995, New Zealand had exactly 51 of these birds left on the entire planet, so they did something almost nobody had tried before at this scale. They loaded every single surviving Kakapo onto helicopters and moved them to islands with no predators at all. Total isolation, total safety, and the birds responded by almost refusing to breed at all. That's only the first mystery in this story. There's a second one, buried even deeper, that most retellings never get to at all. A genetic puzzle that took a team of scientists across 3 continents nearly a decade to even start solving, using tools that didn't exist when this rescue began. 31 years later, in 2026, both mysteries are still being worked out in real time, and the most recent findings aren't the ones anyone would have guessed at the start. The Kakapo is the heaviest parrot on Earth, flightless, capable of living close to a century, and it smells distinctly of honey and old wood, strong enough that you could track one down in the dark by scent alone. For most of its history, none of that was a problem. New Zealand had no land mammals hunting anything for millions of years, so the Kakapo's entire defense strategy was built around one danger from above: freeze, vanish into the moss, wait it out. Then people arrived, bringing cats, rats, and stoats, predators that hunt by smell in a landscape full of animals that had spent millions of years perfecting the art of standing fragrantly still. By the 1970s, most scientists assumed the species was already gone. A tiny group turned up in 1974, all male. A second population with females followed, but cats were killing them fast enough that the clock was already running out. This wasn't even the first rescue attempt either. Back in 1894, a naturalist named Richard Henry relocated hundreds of Kakapo to Resolution Island, believing he'd built the species its first safe haven. Stoat swam the strait separating it from the mainland 6 years later and wiped the population out completely. That failure is the exact reason the 1995 program picked islands so much farther offshore that nothing could swim to them. By 1995, with the population down to 51 birds, officials had run out of smaller options. Every remaining Kakapo got airlifted to predator-free islands under quarantine, so strict that every boot and tool brought ashore had to be sterilized first. And still, almost nothing bred. Between 1980 and 1995, across every nesting attempt, only 3 chicks survived, mostly because rats couldn't kill an adult bird, but could crack open an egg with ease. Once the rats were gone too, and the nests were locked down tight, the birds kept refusing to pair up anyway. Well-fed, safe, and somehow still not breeding, as if some internal switch had been thrown that nobody could find. It took years of watching before a pattern emerged. Breeding clustered around specific years when the rimu tree, a native conifer that can live 5 centuries, produced a heavy fruit crop. Rimu doesn't fruit every year. It masts, going years with almost nothing, then suddenly delivering an enormous crop all at once. In 2015, researchers finally worked out why chemically, overturning an assumption that had stood for decades. Rimu fruit carries unusually high levels of calcium and vitamin D3, a nutrient science had always assumed only animals could produce, not plants. That mattered enormously for this particular bird. A female Kakapo incubates alone for months with no help from a mate at enormous physical cost. Her body appears to use vitamin D3 intake as the actual trigger for forming eggshells at all. No rimu, no vitamin D3 spike, no eggshells, regardless of how much artificial food rangers left out. The bird wasn't being stubborn. It was reading a signal humans hadn't known existed. In 2002, a massive rimu fruiting season opened the breeding window on Codfish Island, and rangers supplemented the females with extra food on top of the natural crop. The logic seemed airtight. Healthier mothers, more eggs. Chicks hatched. Then, researchers checked the sex ratio, and the number stopped them cold, roughly 70% male in a population already desperately short on females. The cause was evolutionary. Male Kakapo grow 30 to 40% larger and take far more effort to rear. When a mother's body senses abundant food, it appears to shift the odds toward producing the bigger, more competitive sex. A strategy that works in the wild and backfires the moment humans start topping up the food supply. The fix was almost the opposite of instinct. Cut the extra food back, keep females fit enough to breed without letting them build up surplus. The sex ratio snapped close to even almost immediately, and that single season, the population jumped nearly 40%. The lesson underneath all of it: you can't just give an animal more of a good thing. You have to give it exactly what it would have found in the wild. This is the part of the story almost nobody covers. It might matter more than anything above. That same year, a completely different team started a project nobody had ever attempted for any species on Earth, sequencing the full genome of every single living Kakapo. Everyone. At the time, there were 125 birds left, which is where the project got its name, Kakapo 125+. Duke University, Rockefeller University, New Zealand's Otago University, a crowd-funded nonprofit called the Genetic Rescue Foundation, all of them working off one reference genome, built from a female bird named Jane, finished in 2018. Why map the DNA of an entire species, one bird at a time? Because the numbers underneath the recovery are genuinely alarming. Genetic studies published in the years since have found that Kakapo have lost somewhere between 70 and 80% of their genetic diversity since the 1800s, and that the birds show clearly poor sperm quality and low hatching success as a direct result. That's not a side detail. That's the real reason so many eggs on those islands never hatch at all, even in a good Rimu year. And here's the twist that actually surprised the researchers. When they compared the genomes of the surviving island birds against genetic material recovered from the extinct mainland population, the island birds, the most inbred group, the ones everyone assumed were in the worst genetic shape, actually carried fewer harmful mutations than their mainland relatives did. Scientists call the effect purging. In a small, isolated population, harmful mutations have nowhere to hide. So nature weeds them out faster and more directly than it ever could in a bigger, more scattered population. Roughly 10,000 years of isolation on that one island may have quietly cleaned up some of the damage a larger mainland population never had the pressure to clean up on its own. That finding changed how the recovery program actually makes decisions. Every bird's genetic profile now factors into which individuals get moved between islands, which pairings rangers try to encourage, and even which females become candidates for artificial insemination when a promising male's genes need to reach a mate he'd never meet naturally. Geneticists effectively rank each new chick by breeding value before deciding which nests get the most intensive protection. A level of individualized management that would have been science fiction back in 1995, when the entire strategy was just keep them alive and hope. As of early 2026, a team at Genomics Aotearoa finished catching up the genome database with every chick hatched since the original sequencing effort, using newer AI-assisted tools to spot genetic variation between individual birds far faster than the original project could. Their conclusion, published this year: 45 years of hands-on management has actually preserved more usable genetic diversity in the breeding population than anyone expected going in. The species isn't just surviving. According to this newer research, it may still have enough room to adapt and handle whatever comes next, new diseases included. That newer research explains the genetics at the population level, but the reason those genetics matter this much traces back to one specific bird, and almost nobody outside the program knows his name. In 1975, rangers searching Fiordland found a single adult male Kakapo, alone, over 1,000 meters up a remote valley wall. They named him Richard Henry, after the same 19th century naturalist whose failed Resolution Island rescue is mentioned earlier in this story. It turned out to be a fitting name for an entirely different reason. Every other Kakapo discovered in the years since traced back to one place: Stewart Island, off the southern coast. This one bird was the last known survivor of a completely separate bloodline, the Fiordland population, carrying genes nobody else alive still had. For over 2 decades, rangers moved him from island to island, watching, waiting. He boomed in a different dialect than the Stewart Island males. His feathers ran brighter green, marked with bold yellow nobody else carried. Then, in 1998, on Maud Island, he finally bred with a Stewart Island female named Flossie. 3 chicks survived, 2 males, Sinbad and Gulliver, and 1 female, Kuya. For the first time since his discovery, his lineage had a future outside himself. Richard Henry went quiet after that. He stopped booming entirely for his last decade, going blind in one eye as he aged. On Christmas Eve 2010, he was found dead on Codfish Island, roughly 80 years old by the program's best estimate. Conservationists who'd worked with him for 35 years called him a national hero most of the country had never heard of. His genes didn't die with him. In 2021, his grandson Sinbad became the subject of the recovery program's first successful artificial insemination breakthrough in over a decade, the same technique now woven into the genetic management strategy from the previous section. Every time a geneticist today flags a bird as carrying rare Fjordland ancestry, they're talking about Richard Henry's bloodline, still working its way through a population that would otherwise be entirely one family tree. Not every part of this story is genomes and nutrient charts. One hand-raised bird became something like the species' unofficial mascot after climbing onto a zoologist's head on live international television in 2009 and attempting to mate with it on camera in front of the world. Rather than bury the clip, conservationists made him the Kakapo's official ambassador, the one bird still allowed regular contact with the public. It's a funny story and also a reminder that every number in this recovery is an individual animal, not just a line in a spreadsheet. Then, in 2019, right as the program was celebrating a record breeding season, disease hit. Aspergillosis, a fungal infection, tore through the dense colony on Codfish Island, worsened by the same inbreeding the Genome Project was already trying to fix. 21 birds were infected. 9 died. To contain it, rangers rushed the sick and exposed birds to the mainland for urgent care. The number they moved, 51. The exact same number the entire species had once been reduced to, 24 years earlier. The most recent chapter started in 2023, when 20 male Kakapo moved to a mainland sanctuary for the first time in nearly 4 decades, behind a predator-proof fence stretching for miles. Kakapo, it turns out, don't read fences as permanent. 6 of the first 10 released birds climbed straight over it, using beaks strong enough to work like pliers. Rangers had to track them down and redesign sections of the barrier. 4 decades into this program, the species is still finding the edges of whatever boundary humans draw around it. This recovery doesn't belong to New Zealand's government alone. The Kakapo recovery team is a formal 3-way partnership. The Department of Conservation runs the fieldwork. A private energy company, Meridian Energy, funds a meaningful share of it. And Ngai Tahu, the Maori iwi of the southern half of New Zealand, sits at the table as an equal partner, not a consultant brought in after the fact. Their representative on the team, Tane Davis, has described the population's genetic problem using a word that carries far more weight in Maori culture than a lab report ever could. Wakapapa, meaning genealogy, lineage, the thread connecting every living thing back through its ancestors. Under that framework, a bird's genetic diversity isn't just a statistic to protect. It's a family history worth protecting on its own terms. That framing shapes real decisions. Traditional place names guide where release sites get chosen. Cultural protocols shape how remains are handled when a bird dies. And the whole recovery effort is treated less like a wildlife management program and more like a shared obligation passed between generations, which may be part of why a rescue now in its 4th decade still has anyone showing up for it at all. Most retellings skip the part that doesn't wrap up neatly. The population kept climbing for years after 1995, reaching a peak of 252 birds by 2022. It hasn't kept climbing since. By early 2026, the number had slipped to 236, worn down by age and disease in a population still genetically descended almost entirely from those original 51 birds. Breeding paused completely for 4 years after 2022, no eggs at all, until monitoring finally detected new mating activity at the very end of December 2025, kicking off what conservationists are calling a potential record season for 2026. This isn't a story with a finish line. It's a species still riding the same Rimu-driven boom and bust cycle it's been riding for 31 years, now watched by radio transmitters and mapped down to the individual gene by researchers who can finally see, more clearly than at any earlier point in this recovery, exactly how much genetic room this bird actually has left to survive whatever comes next. Here's the question worth sitting with. If the species that came back from 51 birds is still this fragile, still this dependent on one tree's mood every few years, but the genetics say it might have more evolutionary room to maneuver than anyone assumed. Was this ever really a rescue? Or is it a rescue that never gets to end, just gets better understood? Type saved if you think the Kakapo has genuinely turned a corner. Type fragile if you think this recovery could still slip backward. This is Hidden Latitude. We go back for the endings nobody's finished telling yet.